right, let's get started with that computation. We are going to look at all four operations, but we're going to start here with addition. We're going to think about addition with decimals in two different ways. First involving the traditional algorithm, and then we'll think about using that partial sums algorithm. With this traditional algorithm, I really want to think about some of the tools that I could use to help students understand what this addition means. And so some good tools that we could use are the base 10 blocks and the place value disks. So let's look at examples of both for this problem right here. Okay, we are going to use the traditional algorithm to solve this problem right here. And first I'm going to do this with my base 10 blocks, where my flats represent 1, my tenths, my rods represent tenths, and my units represent hundredths, all right? Let's go ahead and set this problem up. I have 2 and 16 hundredths. So I'm going to show 2 right there just like that. I'm going to move it into the camera view. All right, there you can see it like that. And I have 1/10, and then I have 6 hundredths. 1, 2, 3, 4, 5, 6. And you know what? I'm going to move my base 10 blocks off of my workspace. So now it starts to be easier to see what's going on. I'll move it all the way off of my workspace so it's not distracting. There we go. Then I'm going to show 4 and 78 hundredths. So that's 4, 1, 2, 3, 4. Can you see those 4 there? I hope you can. And 78 hundredths, so that's 7 tenths. I've got 4, 5, 6, 7, and 8 hundredths. 1, 2, 3, 4, 5, 6, 7, 8. All right, that looks great. So now I'm going to add 2 and 16 hundredths plus 4 and 78 hundredths. With the traditional algorithm, I start in the place value that is the least. Here, that is the hundredths column. So I'm going to go ahead and add all my hundredths together. So I'm going to do the motion of adding them together here. And then I ask myself, if I have more than 9 hundredths, I have to regroup. So let's see what we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm kind of lining them up there for a reason. So I do have more than 9 hundredths. And whenever I have more than 9 hundredths, I have to regroup those. 9 hundredths is equivalent to 1/10. So I'm going to regroup, and then I'm going to put this tenth in the tenths place, and I'm going to lay it there just like that. So how many hundredths do I have remaining? I have 4. I'm going to go ahead and write that there here in my problem. There we go, 4 underneath the equal line. And then remember, I regrouped at 1/10. I'll go ahead and write that there just like that. That's my notation. Now it is time for us to add the tenths. I'll go ahead and add all of those together. If I have more than 9 tenths, I have to regroup. Let's see if I do. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I do not have more than 9, so I don't have to regroup. So I have 9 tenths. I'll go ahead and write that underneath the equal line just like that. And then it's time to add my ones together. I'll go ahead and add those together. I have 1, 2, 3, 4, 5, 6. Whew, that's a whole lot. I don't have more than 9. I don't have to regroup. So then I'll go ahead and write my 6 right there. Now what is missing? My decimal point. So when I add 2 and 16 hundredths plus 4 and 78 hundredths, my sum is 6 and 94 hundredths. So that was one of the ways that I could do that problem with the base 10 blocks. I'm going to go ahead and remove my base 10 blocks here because I want to see if I can do this same problem with my place value disks. Now, my place value disks are these little colorful disks here. We've used these before in this module. So first I'm going to show 2 and 16 hundredths. And I like these place value disks because they're pretty easy to manipulate. And they take up, you can see, a lot less space than I had with my base 10 blocks. So I showed 2 and 1600ths. And I'm going to add 4. Going to go ahead and show that second add in there first. 4 and 7800ths. So I need 1, 2, 3, getting them all ready, 4, 5, 6, 7. And then how many hundredths do I need? Let's see, I need 1, 2, and I've got to get my others out here. Let's see, 3, 4, 5. And you know what? You can't see this, but my hundredths fell on the floor. So I'm going to have to pick them up off the floor to be able to use them. So I've got 5, 6, 7, 8. Found them pretty easily. Ah, there we go. So now I'm going to add. The traditional algorithm asks me to start adding in the least place value. I'm going to go ahead and add these together. And then if I have more than 9 of these, what do we have to do? Well, we have to regroup. So let's go ahead and see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, let's see, what do I have hundredths? 10 hundredths is equivalent to 1/10. All right, I'll go ahead and do that there. And so now I have 4 of these, 1, 2, 3, 4. And I could go ahead and check that over here with what I wrote earlier. Now let's add our tenths. If I have more than 9, I have to regroup. We don't have more than 9, so we don't have to regroup. And now I add my ones. And I see I don't have more than 9, so I don't have to regroup. So let's check to see if what I did earlier is confirmed with my place value discs. My sum is 1, 2, 3, 4, 5, 6, and that's 6 and 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then 6 and 91 hundredths, 92 hundredths, 93 hundredths, 94. So our sum, as we decided, is 6 and 94 hundredths. So those were 2 examples where I could use the base 10 blocks or my place value discs to help students understand what it means to use the traditional algorithm when I'm adding these decimals. So we just looked at an example where we used the traditional algorithm and we used both base 10 blocks and place value discs. Let's look at how we could use the partial sums algorithm to help students with this computation of decimals. And now we're going to use a different manipulative. Let's use some money. So here's what that might look like. Here I'm going to draw vertical lines to separate my place values. That's always helpful to really help me focus on the ones, the tenths, and the hundredths. And then I'm going to show both add-ins with manipulatives. Here I'm going to show the first number as $2.16 and the second add-in as $4.78. Now with the partial sums algorithm, we start adding with the greatest place value. So here, $2 plus $4 equals $6. And then I think about adding in the tenths. Here, 1/10 plus 7/10, or 10 cents plus 70 cents, that would be 80 cents. And then I move to the least place value here. Here I have 6 hundredths plus 8 hundredths, or I could think about that as 6 cents plus 8 cents. That would be 14 cents. Now do see how I did my regrouping there. So I went ahead and did my regrouping, and I also wrote my partial sums below the equal line. To figure out the answer to this problem, or what I would want to call it the sum, I can add those partial sums together. So when I add $6 plus 80 cents, that's $6.80 plus 14 cents more would be $6.94. Or if I'm just interpreting that in its decimal form, that's 6 and 94 hundredths. So those were some examples of how you could use different tools to help students with addition of decimals. We looked at base 10 blocks, we also looked at the place value discs, and we also looked at money. So would you use the base 10 blocks, the place value discs, or money to help students understand addition of decimals? And I'd like you to explain your choice.